Did anyone get any final answer here for this? Any final answer? Let's see what let's do it and then see what you got. Right, so here we have to multiply and then divide. These are all in rectangular form. So remember with division, you need to remember multiply by the conjugate of the denominator. But now in the numerator we can remove the brackets first. It's up to you what you want to do. Okay, so let's remove the brackets here. 4 times minus 3 is minus 12. 4 times 7j, that will be 28j. And then minus 2j times 3 will, minus 3 will be plus 6j. And then minus 2j times a negative times a positive, that will be minus 14j squared. All divided by 5 minus j. Let me simplify the numerator as far as possible. So now we got minus 12, and then we got 28j plus 6j, there will be 34j. And then we have minus 14 multiplied by j squared. But remember, what is j squared? J squared is minus 1. And we're dividing by 5 minus j. So I can simplify further. So I have minus 12 plus 34j, and a negative times a negative is positive 14 divided by 5 minus j. So now this is equal to 14 minus 12, which is 2 plus 34j, all divided by 5 minus j. So I simplified the numerator, nothing more I can do in the numerator. Now this is strictly division. So how do we divide in rectangular form? You multiply this expression, numerator and denominator, by the conjugate of the denominator. Remember, what do we want to do here? We want to make 5 minus j, this is a complex number, and we want to change it. It needs to become a real number. So in order to do that, I multiply by the conjugate. If it's 5 minus j, you multiply by 5 plus j in the numerator, in the denominator and the numerator. Because remember, 5 plus j divided by 5 plus j is just a positive 1. We are not changing the question in any way. Alright, so now let's multiply. 2 times 5, that will be 10. 2 times j, that will be 2j. Then 34 times 5 there, 150, 170, correct. That will be plus 170 j, and then remember that 2 times 5 is 10, 2 times j is 2j, 34j times 5, that will be 170j, and then 34j times j, that will be 34j squared. And the denominator is the difference of two squares. There's no need to go and multiply every single thing out. You only deal with the first and the last. So this will be the difference of two squares. So that's 5 squared minus j squared. Right. So now this is going to be a 10 plus 170 plus 2. That will be 172j plus 34 times j squared. And 5 squared here is 25 minus j squared. So remember, wherever you see j squared, minus 1, you substitute negative 1. So now this will be a 10 plus 172j, positive times your negative there, that will be a minus 34. And here we get 25 plus 1. Negative times negative is positive. So now what do I have here? I have 10 minus 34, which is minus 24 plus 172j, all divided by 25 plus 1, which is 26. Now, I can simplify. I'm going to separate this into its real component and imaginary component. That's what you need to do. So that's minus 24 divided by 26 plus 172 divided by 26j. This can be simplified further. What can we can divide? So that will be 12 over 13. That's going to be minus 24 divided by 2. That's 12. 26 divided by 2. That's 13. Here, can we simplify this here? So that will be, what will it be there? 150, 172 divided by 26. Simplify that. 86 over 13. Correct. So that will be 86 over 13j. Let's check if this answer is correct. Alright, so now for those of you who have this calculator, right, so if you have this calculator, then this calculator can work this out. You can see it was quite a bit of work here. So what do? We press mode and then you go to number 2. Number 2 is complex then. Okay. So only for those who have this calculator. So number 2 is complex. And now what do? Let's type out 4 minus 2j times minus 3 plus 7j divided by 5 minus j. So what am I going to do? I'm going to press the fraction button here. Then my numerator there, open bracket, I got 4 minus 2j. So that's going to be a 4 minus 2, and the j is the ENG button on your calculator. The ENG button, so that's I. So the calculator uses I instead of j. So that's 4 minus 2j there. Close times minus 3 plus 7j. So that's minus 3 plus 7j. Close there. So we can see that. And then we got 5 minus j. So that's divided by 5 minus j. So let's have a look at this. So it's straight on the calculator for those of you who got it. Or you can download this on your smartphone so you can check your answers at home. But you cannot obviously take your phone in the exam. Let's see, what is this equal to? Minus 12 over 13 plus 86 over 13j. So that answer is 100% correct. You see, it only takes a few seconds to check on the calculator. Alright, so that was multiplication and division in rectangular form. We're still going to be dealing with in a few minutes, multiplication and division in polar form. But before we do that, remember that j squared is negative 1. Now, if you're given any other power besides a positive 1, then you need to simplify it. So your answer must be in terms of j. Okay, so now you cannot have j to the power 3, you must just have a j. Oh yeah, look, j to the power 27. Here you can see there's many multiples of j. So what do? We remember that j squared is negative 1. So now we need to apply our exponent laws here. So if I got j to the power 3, so j to the power 3, how can I rewrite this? Remember, the key factor here is to obtain j squared from whatever we have here. Simplify it and get j squared. So if this is j to the power 3, so j to the power 3 will be the same as j squared multiplied by j. Exponent laws, because x to the power 3 is x squared times x. So what did I do now? I split it up. This is j to the power 1. You don't have to write down the positive 1. Okay. So now, what do I know? I know that j squared is minus 1 times j, which is minus j. That's all. Simple exponent law. That's how we deal with powers of j. Let me give you a few minutes. Let's see what you can do now. It's all about exponent laws. What do you need? J squared. Simplify it, get j squared. Alright, j to the power 27. What can we do here? J to the power 27. Alright, so in this case, now j to the power 27, if I split it up and it becomes j to the power 26 times j to the power 1. Okay, now why am I splitting it up into 26 and 1? Because 26 is an even number and the number 2 is also an even number. That means 26 can be divided by 2 evenly. Okay, so therefore I can write this as j squared all raised to the power. What will I put down there? If I write down a 2 there, what will I write down as the higher power? 13. Okay, because here I'm using the exponent law. When you have a power raised to a higher power, you multiply the exponent. So there's a j. If I have x to the power a all raised to the power b, this is the same as x to the power a times b. Now, it's faster to do it this way. So now all you want is your j squared. What is j squared? J squared is minus 1, and then minus 1 to the power 13 times j then. Can you see that? So what is minus 1 to the power 13? It's going to be minus 1 times j. And you're done. Okay, if you wanted to, you could have written it down as j squared times j squared times j squared times j squared. And obviously it's going to work, but you know your exponent laws, try for the quickest method. So the quickest method is to split up your power so you get that even power. So any even number can be divided by 2. Okay, so if I had like 101, I will split it up into 100 and 1. So the 100 can be divided by 2. So it's going to be j squared all raised to the power 50. Okay, next one. Let's deal with the next one. So now there are many multiples of j. What can we do? When we are multiplying and the bases are the same, what do we do? Write down the base once, add the exponents. You can go and do each one individually. Okay, you can split up that, it's up to you. But what happens if I wrote down maybe 15 multiples of j? How long are you going to take to go and split those 15 up? So therefore, that's why exponent laws come about. You need to simplify this into just one single base there. How many bases do you have? 1, 2, 3, 4, 5. You know when you are multiplying and the bases are the same, you're going to write down the base once and add the exponents. So now let's multiply the coefficients first. So your coefficients here are 2 times 3 times 4. So 2 times 3 is 6, times 4 is 24. Then I got j there. Let me just simplify everything now. So when I'm multiplying and the bases are the same, add. So that's 2 plus 29, which is 31, plus 3 is 34. Can you see that? In the denominator, I'm multiplying and the bases are the same, so 7 plus 5 is 12. Okay, you can see it's much easier this way than to do each one individually. Now, I can divide. The coefficients divided by the coefficient. 24 divided by the number that you cannot see is a positive 1. So 24 divided by 1 is 24. What am I doing now? When I am dividing and the bases are the same, I will write down the base once and I subtract the exponents. So that's going to be 34 minus 12, which is 20, 22. So now 22 is an even number. So therefore, that's going to be 24. I need my j squared, and any even number can be divided by 2. 22 divided by 2 is 11. So now that will be 24 j squared is minus 1 to the power 11. So minus 1 to the power 11 is minus 1. And then minus 1 times 24 is minus 24. Let me just add on one more example, yeah? J to the power 3 plus j to the power 5325. So do that, only takes a few seconds if you know, if you understand exactly what I showed you here with the exponent clause. Right, so let's deal with this one before we deal with multiplication and division. So here I got an addition sign. So I need to work out each one individually. Here it was multiplication. I did not have to work out each one individually and then multiply. I could have done it, but it's not an efficient way. It will take too long. So that's why you simplify it to a single base only. Now here, no exponent law will apply here because there is a plus sign. Right, so now I will work out j to the power 3 individually. So j to the power 3 will be the same as j squared times j to the power 1. J to the power 5325 is the same as j to the power 5324 times j to the power 1. All you do is split it up, just like how we did it here. So now I know that j squared is minus 1. So this j squared here is minus 1 times j. You're clear with that? Then plus, when I take away 1 from any odd number, whether it's 1,000,001 or 1,023,000, you take away 1 from an odd number, it's going to become an even number. Can you see that? So any even number can be divided by 2. So that's going to be j squared, and 5324 divided by 2 is equal to
2662.
2662 times j to the power 1. Alright, so now that's going to be minus 1 times j is minus j plus j squared here is minus 1 to the power 2662 times j. So therefore, I get minus j plus negative 1 raised to 2662 is going to equal to a positive 1. Okay, so that's going to be 1 times j. So clearly minus j plus j, yeah? That is 0. Be careful, use your calculator there. Alright, so now something new, a new rule to learn now. So that was powers of j. So now we're dealing with multiplication and division in polar form. So polar form is when you have your r, which is your modulus, and your argument, your angle there, which is theta. So now, the rules for multiplication, division, and then exponents. So here's two complex numbers in polar form. I've got z1 is equal to r1. You got your angle theta 1. Z2 is equal to, sorry, I forgot to write down. This one here is Z2 is equal to R2 theta 2. Okay. So now, if I am multiplying in polar form, right, so I've got two complex numbers in polar form, Z1 times Z2, so there's the multiplication. So what is the rule here? The rule is multiply the R values. So there's R1 times R2. That means if this was a 2 and that was a 3, 2 times 3 will be 6. And then what do you do to the angles? You add the angles up. So if this was 20 and this was 30, 20 plus 30 will be 50. That's all. Multiply the R's, add the angles. And then for division, you do the opposite now. You divide top divided by bottom. Top R value divided by the bottom R value. And then top angle minus bottom angle. Right, nothing difficult there, just remember that. Then, what happens when you have exponents now? Okay, it's called the Moivre's theorem, but you can remember it as exponents because you are dealing with an exponent here. So if you have something like a polar, you have your complex number in polar form, and you have an exponent, what do? You raise R to the power, whatever your power is there, and then you take the same exponent and you multiply it by the angle. Okay, so that is the rule. Example, let's take an example here for this one here. If I have Z is equal to 2 and I got my angle 25 degrees, all raised to the power 2. So there's my R1 which is 2, theta which is 25 degrees, and my exponent n is 2. So what do? You raise R to the power n, so that's going to be 2 to the power 2, and then you take the same exponent and you multiply it here. So that will be 2 times 25 degrees, which is equal to now 2 squared, which is 4, and 2 times 25 is 50. So we simplify it, so at the end you only end up with R and theta. Then it depends on the instruction, what you need to do, like the example I'm giving you here now. Okay, so this is exponent laws. Now, notice I have an exponent here, but inside the bracket is not polar form now. You've got A plus JB, which is rectangular form. So what do you do in a situation like this here? You will convert from rectangular form to polar form, so you can apply the exponent laws, because there's no exponent law for rectangular form. Like maybe if you have a square, it's easy to square it out. But the problem is, what happens if your power is 15, or if it's negative 6 or negative 7? Then what you're going to do is, you must remember how to convert from rectangular to polar form. Then once it's in polar form, you apply your exponent law and then simplify it. Now, let's take an example here. So I am multiplying and dividing. This is in polar form. So what will I do here? I can work out the top first. Can you see that? So here I got 2, you got your angle 30 degrees, that's 10, 45 degrees. So in the top I can go 2 times 10. And then since this is multiplication, I can add the angles up, which is 30 plus 45 degrees. Okay, then I got 5 there and my minus 25. I'm not interfering with this at the moment. I want to work it out individually, the numerator first. So 2 times 10 there is 20. And then I got 45 plus 30, which is 75 degrees, all divided by your angle 5 there, that's minus 25. So I simplified the numerator, I multiplied it. You can see that? Now this is division. So how do we do division? It's top divided by bottom, and for your angles, it's top angle minus your bottom angle. So this is going to be 20 divided by 5, and then top angle is, the top angle there is 75 minus, what's your bottom angle? Your bottom angle is minus 25 degrees. So the rule is top angle minus bottom angle. You can see it. Theta 1 minus theta 2. So therefore, top minus bottom there. So 20 divided by 5 is 4. And then I got 75 plus 25. Now because a negative times a negative is positive, so that's going to be 75 plus 25 degrees. So that's going to be 4, and that's going to be 100. So this, at the moment, it's simplified. So what have we done now? We've simplified it into just R, one R value, one theta value. But now, read the instruction in the exam. Most of the time, when they ask you to simplify something in polar form, they'll say leave your final answer in rectangular form. So now, remember, converting from polar form to rectangular form. Let me just refresh your memory there. So if we have Z is equal to R and your angle theta, if I want to convert from polar to rectangular, then it's going to be R cos theta plus R sin theta times J. And that's the formula for converting from polar to rectangular form. So let's do it here. So this is going to be 4R, which is 4 cos theta, so that's going to be cos 100 plus 4 sin theta, which is sin 100 times J. So work that out for me on a calculator. 4 cos 100 degrees. Round it up to 3 decimal places if possible. I can't hear.
Negative 0.695.
695. And this one? For sin 100?
3,
Positive or negative?
positive
3 comma
940.
3 comma 940. Everyone is happy with that answer? Everyone gets the same final answer there? Nobody says yes, that means this is wrong. Okay. Give me your calculator. You get the same thing? Then why are you not saying yes? If nobody says yes, that means, I assume, most of the time it's wrong. Okay, let me just double check here. So that's 4 cos of 100 minus 0.695. That is correct. And then 4 sine of 100, 3.939. Yeah, so this is okay. This one here is supposed to be 939. Rounded up to 3 decimal places. Because there is no fourth decimal place of 9 there. So this is going to be 3,939. Everybody must get the same final answer rounded up to 3 decimal places. In the instruction in the exam states all final answers must be rounded off to 3 decimal places. But if you had 940, they will not penalize you, understand that? But this is engineering, we need to be, everyone must be 100% accurate here. So we're not rounding off, we did not use the calculator anywhere except at the end. Alright, so now we are multiplying and dividing in polar form. Alright, but now what do you notice? Here, when you see the small circle or exponent that looks like a circle, it means degrees, that is a symbol for degrees. But now if you do not see anything here, that means it is not in degrees now, it will be in radians, okay? So, this is pi in radians. If you convert this to degrees, it will equal to 180 degrees, okay? Now, there's two ways to deal with this here. It's either convert all that to degrees and then divide it, or work with it as it is. You got the pi button in your calculator and convert your calculator to radians now. So you look for this mode here and you will convert your calculator to radians before you go and do anything on the calculator. Alright, so you got pi is in radians. Clearly there is no degree symbol here. You don't see the degree symbol. Can you see that? So now, that's the only thing you need to be careful of. For the rest is simple. When you're multiplying, multiply your R values, so that will be, now let me show you what happened. If you compare the previous one, what we did was we worked out the numerator first and then we divided. Okay, we can't do it in one step because this is multiplication and that's division. So watch here. If you want to do it in one step, you can. So this will be 3 times 4, and when you're done with that, you're going to be dividing by 7. Can you see that? So there's my R1 times R2 divided by R3. You multiply and you divide. Now, let's deal with the angle. So here, when we are multiplying, we add the angle, so that will be pi over 3, and then you got minus pi over 4. And then when you are dividing, what do? You subtract. So that's going to be a minus pi over 6 there. Are clear with that? Simple. When you are multiplying, add. When you are dividing, subtract. So you might wonder, why is this a negative? It's because I'm adding it. What actually happened there is pi over 3 plus minus pi over 4. This is addition now. So when you remove the brackets, it's going to be pi over 3. A positive times a negative is negative pi over 4. So it's unnecessary to go and write the plus. You should know, you've been doing this adding, with negatives and positives there. So now, let's simplify this part here. Simplify this part here also. So 4 times 3, that will be 12 divided by 7 there. And here, what do we get? You got your fraction button on the calculator. Use it. This is pi over 3 minus pi over 4 plus pi over 6. I can find the LCD there of 12, so that's going to be 4 minus 3, which is 1, plus 2, which is 3. What's going to be pi over 2? No, 3 over 12, pi over 4. 1 over 4 pi. Okay, pi over 4 is anything. 1 over 4 pi. So that's going to be 1 over 4 pi. Right, so nothing difficult. You got your calculator to add up all your fractions. So what happened here now? This is simplified. So basically you got r and you have your angle now, theta. It's simplified in polar form, but I'm giving you an extra instruction here, which is convert your final answers to rectangular form. So to convert from polar to rectangular, so that's going to be r cos theta plus r sin theta times j. So that's going to be 12 over 7 cos of 1 over 4 pi plus 12 over 7 sine 1 over 4 pi times your j. Now, calculator in radians first, so that's going to be shift. You'll know how to convert from degrees to radians, eh? Your calculator must be in radians when you have pi. Okay, when you're using pi. Right, so it's converted, so I got my 12 over 7. That is cos 1 over 4 and pi. So here I get 6 root 2 over 7. You get the same thing. And then just delete the cos and put sine. And this is going to be plus 6 root 2 over 7 j, which is basically 1 comma 2 1 2 plus 1 comma 2 1 2 j. You'll get the same thing. So you do each one individually. You do this one, write down your answer. Do this one individually. Okay, so here the only difference now is we have the exponents to deal with. So now what you do is you apply your exponent law first. So here this is going to be 3 to the power 3. So what you do is you raise r to the power and then you take that same exponent and multiply it by the angle. So that's going to be 3 times minus 45 degrees here. So that's going to be 2 to the power 4 and then that will be 4 times minus 30 degrees. So that is it to deal with the exponents, and then the rest is the same. So this is going to be, we got your 27 there. This is going to be 1 to minus 135. And this is 2 to the power 4, which is 16. And this is minus 120. Now, it's a simple division in polar form problem. So then we have 27 divided by 16. And now we have top angle subtract the bottom angle. So that's going to be minus 135 degrees minus 120 degrees. And then we can simplify. So we got our 27 over 16 there. And that's going to be minus 135 plus 120 degrees. So that will be 27 over 16, and that's going to be minus 15 degrees. Now, this is simplified in polar form. I gave you an additional instruction, so let's convert this. So that's going to be 27 over 16 cos of minus 15 degrees plus 27 over 16 sine of minus 15 degrees times j. Give me the calculator. Remember, we are gone back to degrees. So your calculator, you convert it to degrees before you do the calculation. So that's 27 over 16. So that will be cos of minus 15 degrees which is 1,63. And then we have 27 over 16 sine of negative 15 minus 0,437 j. You got your calculator in scientific mode, that's why it's 10 to the power minus 1. Let's put it. Let me just redo this. 27 over 16 sine of minus 15 minus 0,437 here. Alright, so that was dealing with the exponents. Now, this type of one. Okay. Here, we are multiplying and dividing, but this is, we have exponents now. Can you see that? We are dealing with exponents. So, we are not, it will take too long to go and take 1 plus j and multiply it 3 times. Okay, 1 plus j times 1 plus j times 1. It can be done that way. You take 1 plus j and write it down and multiply 1 plus j times 1 plus j times 1 plus j. This one, okay, this one you can do it one time because it's a square. Here, are you going to go and write this 4 times? Square root 2 minus square root 3j. Square root 2 minus square root 3j. 4 times. Imagine, I can change this and write 100 here. What are you going to do? Are you going to write it down 100 times? No. So, you need a way that no matter what exponent is given to you, you are able to deal with it easily. Okay, so what do? We know that this works nicely when you have something in polar form. So if I can have r and theta, then all I have to do is raise my r to the power, whatever the power is, okay, and multiply by theta. So what we must do here is convert this, find your r, find your theta there, and then write it down. Convert this, find your r, theta. So you need to convert from rectangular form to polar form. Let's take this one here. Let's take this one here, just to refresh your memory. So what I'm going to do is, I'll say, okay, let's write down everything. First, I'll say let 1 plus j equal to r1, theta 1, and then minus 3 plus 4j equal to r2, theta 2, and let the bottom one, which is square root 2 minus square root 3j equal to r3, theta 3. Right, so I want to find r and theta for everyone. So remember, how do you convert from rectangular form to polar form? You got your calculator. I showed you how to do that. But now obviously here you need to write down the formula for your modulus to show that you're working it out without a calculator. Alright. So now here, remember r1 is equal to the square root of a squared plus b squared. So that's going to be, remember your diagram, theorem of Pythagoras. So that's going to be 1 squared plus 1 squared. So that will be the square root of 1 plus 1, which is 2. Let's just leave it as it is for now. That's the square root of 2. Then, to make sure that we are in the correct quadrant there, so let's do a rough sketch. You're not getting any marks for the sketch here. It's just to direct you to the correct quadrant. So what do we know? That's a 1 and a 1. So there's 1 there, 1 there. So you are in quadrant number 1. So in quadrant number 1, your theta 1 is going to equal to, straightforward, inverse tan B over A. So that's going to be inverse tan 1 over 1, which is equal to 45 degrees. So you got your R, you got your theta, that is sorted out. Let's do it here now. So here, R2 is equal to the square root of, same thing now, you know, A squared plus B squared. So your A and B here, so that's going to be minus 3 squared plus 4 squared. So that's going to be 9 plus 16, which is the square root of 25. This is a perfect square, which is 5. Now, remember your quadrant here. So, here, the real value is negative. Can you see that? Minus 3, so where is minus 3? Minus 3 is somewhere around here. And the imaginary value is positive, so you're going up 4. So remember, this is your imaginary axis, that's your real axis. So we're going up 4, so you know you're going there. So your angle theta lies in the second quadrant. Second quadrant, so therefore theta 2 will equal to, in the second quadrant, we're going to go 180 minus inverse tan B over A, and we use the positive values here, remember that? So that's going to be 180 minus inverse tan B over A. So I'm going to ignore the negatives, so I'm just going to go 4 over 3. You're going to get your answer there. Alright, give me the answer here quickly for this one. 180 minus that.
It's 126, 86.
126,
86.
86 degrees. And all got that? So this one example that we're doing here basically covers almost the whole section or the whole chapter on complex numbers here. Right, so we converted from rectangular to polar, rectangular to polar. Let's deal with this one here. So here your R3 is equal to the square root. I'm not writing down the formula now. You know that's going to be A squared plus B squared. So that's going to be 2 plus 3. So that's going to be the square root of 5. Now to get your angle, which quadrant are we dealing with now? That's a positive number, so that's on the positive side. That's your square root 2 there. This is a negative number, so we're going down. So that's going to be minus root 3. So you're going there, there. Clearly, we are in the fourth quadrant. Can you see that? Fourth quadrant. So in the fourth quadrant, we're calling this theta 3. What do we use in the fourth quadrant? That's going to be 360 minus inverse tan B over A. So that's going to be 360 degrees minus inverse tan B over A. So if I'm using this, I'm ignoring the negatives in the calculator here. So that's going to be square root 3, square root 2. Give me the answer there quickly.
309, 23.
319, comma 23 degrees. Nothing difficult here. Nothing difficult. Okay, it's only 180 minus second quadrant, 180 plus third quadrant, 360 minus fourth quadrant. But you have to do it all the time in order to remember. So now, we have all that information. What do we do? So let's fill it in and work it out. So therefore z is equal to now. So we got that to the power 3. The second one is to the power 2. And the denominator there, that's to the power 4. So 1 plus j is no more 1 plus j now. What is 1 plus j equal to? It's going to be square root 2 and 45 degrees. Minus 3 plus 4j is now 5, and your angle there is 126, 86 degrees. The denominator, square root 2 minus square root 3j is no more than it's converted to polar form, which is the square root of 5, and then we have 319,23. And now it's similar to the problem that we just worked out a few minutes ago. Alright, so now what do? We need to apply our exponent laws in polar form. So what's this going to be? Square root 2 to the power 3, and then we have 3 times 45 degrees. This is going to be 5 squared, and that's 2 times 126, 86 degrees. Denominator, that's going to be square root 5 to the power 4. And then take your exponent, multiply by your angle there. So that's going to be 4 times 319,23 degrees. Okay, so now, what is going to happen now? We're just going to multiply, we're going to divide, and then for the angles, when we are multiplying, we add, when we are dividing, we subtract. So I'm going to multiply here, so that's going to be square root 2 to the power 3 times 5 squared divided by square root 5 to the power 4. I'm just skipping a step and going straight to the multiplication and division. Right, so here, what we're going to do here is, we got 3 times 45 there, which is 135 degrees. Okay, plus we need to add this one up. What is this one here? 126. That will be 252. Just give me the exact figure there. 2 times 126, 86. Multiply by 2 there.
253.72.
253.72 minus. Now why am I subtracting? Because I'm dealing with the bottom angle now. Can you see that? Do this 4 times 319,23. 4 times 319,23.
So 127.92. 1276.92.
92 degrees. Okay, so now let me work this part out, Jeff. Give me the calculator. So I need to work this part out, which is square root 2 to the power 3 times 25 divided by square root 5 to the power 4. So basically this simplifies to 2 root 2 here. Double check me on the calculator there. And then we got 135 plus 253,72 minus 1276, comma 92. So I'm getting minus 888, comma 2. That's what I'm getting here. Now, you can convert this to an angle that's in between 0 and 360 degrees. You might see that in some of the, maybe in the exam memos or the textbook. So, this minus 888, comma 2, if I add 360 degrees to it, that's going to equal to minus 528, comma 2. If I add 360 degrees again, I keep on adding 360 degrees until I get a positive answer. So that's going to be minus 168, comma 2. If I add 360 degrees again, this is going to equal to 191,8 degrees. So you could use 191,8 degrees, or you could use minus 888,2. You will get the same answer. Right, you must try that out. I'm going to use it as it is. So you will find when a negative angle is converted to positive, you add 360 degrees to it. Okay. So I'm going to go straight and I'm going to go 2 root 2 cos of minus 888, comma 2 degrees plus 2 root 2 sine of minus 888, comma 2 degrees times j. So that's 2 root 2 cos of minus 888, comma 2. I'm getting minus 2, comma 769 here. And here it's minus 0, comma 578 j. Just double check everything. I was working fast on the calculator. So that's minus, let me just check that negative angle here first, minus 888. So remember, with the advanced calculator, you can do this also. So you can type this out as it is and check if your answer is correct. Now, in the exam, you're not going to get this one. I just made it up now, right? Because I'm taking 1, 2, 3, and I'm making you multiply and divide it. It will take too long in the exam. So in the exam, you might be just given Z is equal question like this here. Z is equal to minus 3 plus 4j to the power 5, whatever. And this will be your 6-mark question, just for one part only. Okay, so what must you do here? You must convert from rectangular form to polar form, just like how we did only once. Then apply your exponent law and then come back to rectangular form. It's just that here I'm making you do it 3 times, all in one example. So the things that I'm doing here might be, it's more involved. So when you see the exam paper, it'll be easy for you to deal with it. Alright, so what I have done now is I have used this calculator here to verify my answer, if it's correct. Okay, and Clearly it is wrong now, right? So now this is for anyone who's also going to be watching this here. So what I did was on the calculator, I punched in this here as it is. Okay, so let me just do it and show you. For those of you who are going to use this calculator, you can see. So I went to mode, I went to complex, which is number 2, and then I typed my fraction button there. So here is my fraction button, and then as it is on the board, I type it out. So I'm opening up my bracket, and then I got 1 plus j, and that's raised to the power 3. Alright, so now what else do I need to do? 1 plus j to the power 3, then I have minus 3 plus 4j, all raised to the power 2, so that's my square there, and in the denominator I have, what is it here? Square root 2 minus square root 3 j, and that's closed bracket there, and raised to the power 4. So this is what I have done now. Okay, so and clearly it shows now my answer is not correct. The correct answer is minus 1.748. Write that down. Minus 1,749. That is your real value. And the unreal part is minus 2,223 j. Minus 2,223 j. So now, thanks to this calculator, I now know that this final answer is wrong. So what I'm going back and I'm converting everything. So I converted this one, I see the first one is correct, the second one is correct, the problem is with the third one. Okay, so the problem is with the third one, but anyway, maybe it's a good thing that whoever's watching or y'all can see now that how you correct a mistake now. You see that? So what was the angle here now? What was the angle there? This answer was wrong. This is supposed to be 309. Okay, it's supposed to be 309. So what does that affect now? So we go, and there is a problem here. Okay, lucky it was only one thing here. So this is a 309,23. So therefore, now multiply this here for me. 4 times 309,23. Everyone do it now, so we'll know who's making a mistake here. So 309,23 times 4, what do we get here?
1236.
1236,92 degrees. Now do this for me on the calculator. That plus that minus that. Let's see what we get. Make it fast, like how you type on WhatsApp. What's it? Minus?
Minus 848.
848,2.
0.2.
Okay, so that will be 848,2. So that's 848,2 here. That's gonna be 848,2. So let's do this on the calculator now. Give me the calculator. You can double check now. Let's see if we get the curve. There's no other mistake here now. So that's 2 root 2 cos of minus 848, 2. Okay, now I'm getting, so this one here is completely wrong. Now I'm getting minus 1,749. It won't be 100% according to what we worked out on the calculator, but it's very close because of our rounding off. We rounded off all our angles there. Okay, what was the answer I gave you on the calculator? I told you to write down.
Negative 1.749.
Also, it's the same thing. Alright, so most of the time it won't, a few decimal places will not be the same there because of the rounding off. Okay, let me do this part here. So that's 2 root 2 sine of minus 848 comma 2, and then I'm getting minus 2 comma 223j. What answer did I give you all before? Same answer. Okay, so anyway, mistakes happen, but you must know how to correct it. That's the main thing. You must realize your mistake and you must know what to look for, and you need to do it very fast. If this was an exam, now imagine that you have to go back and start checking everything. That's why it's an advantage to have that advanced calculator. Not this one here. This is the calculator that will solve your problems. Alright.